Yes, thank you. Always remind me to record. Okay, great. So we're just going to pick up right where we left off. And today we're going to start by talking about data types, which we kind of skirted around last time. But here we'll kind of formally learn about all of the data types and data structures in R. These are going to be similar to other programming languages, but there are some unique things within this particular programming language. So hopefully we'll all learn something here. So probably the easiest one is the numeric data type. So this is a number. I am creating an object called this is a number. And if I run this, you'll see it show up right in the global environments area, and it's stored as 1. And the way that we are able to check whether or not a particular data type is of the numeric data type is via this function, which is within this other set of broader class of functions that will help test that, right? And so is.numeric is the function name, and then the input is whatever it is that you want to test, whether it's a number or not. So we're going to put in this is a number, and if I run this, what do you guys think will happen? It'll spit out true. Great, perfect. So this showed up last time where we had this number that had an L. Actually, I don't remember exactly where it showed up in our last lecture, but this is a particular unique type of number that's stored specifically as an integer. And so programming languages will do this for several reasons. It is to indicate that a number is exactly an integer. There are some memory benefits to it, and there are some functions and things that you can do specifically with integers that are unique to this sort of class. I wouldn't say that you guys are really going to be dealing with this too often, but it's good to at least know so that whenever you see this thing pop up, you'll be like, okay, it's just an integer, right? So is integer, this is an integer. Test this, and it'll say, it'll say not found because I didn't save it. All right, there we go. So true. So then, what do you guys think? Is integer, this is a number. So the first one, which we know is numeric, do you guys think that's an integer? True or false?
Depends on how it interprets numbers that don't have decimal places. I guess it could be.
All right. If I run this, it's false. Okay. Even though it looks essentially like an integer, and we're essentially treating it as an integer, it doesn't follow the qualifications of the data type that we're indicating that it's actually an integer. So one thing to keep in mind. And what about this? This is an integer. So integers aren't numeric. Sorry. Numerics are not integers, but are integers numeric? What do you guys think? Yes. True. Okay. So simple rules for this thing. Integers are always going to be numerics, but numerics are not always going to be integers. Okay. What did I just say? Integers are always numeric, but numerics are not always integers, even if they look like an integer.
Okay, got you. Thank
Yeah. Okay. The next data type that we're going to look at is a character. In other programming languages, you may know this as a string. basically the same thing. So this is a character, and I stored it as this object contains the character hi. And the way we test this, surprise, surprise, is dot character. Okay, and I run that, and that's true. Okay, great. The way that you denote a character is with the quotation marks. You can use either or the single, I guess it's apostrophe or double apostrophe. I don't think that's actually called an apostrophe, but you know what I'm talking about. The single quotes versus double quotes. They both work functionally the same. You can, one of the reasons why you would use both is you can, if you were to use single quotes and then single quotes within the single quotes, it would just end the character, right? And so if I wanted to say, Adam said hi, it would look something like this, but then this is no longer a character string, right? And so you can use alternating between single quotes and double quotes to get around that issue, okay? But functionally, they're the same, and it's up to you whichever one you want to use. Okay, we did see, yes.
I think one time I was trying to read an Excel file.
Yep.
Directory of my computer, and one didn't work. Like I was trying to see whether the single or the double quotes works, and one wasn't working correctly.
Okay. There could be a lot of kind of things hidden in there that would be kind of hard to parse out as a generalization. But I would generally say that the single quotes versus double quotes are interchangeable. There may be like other reasons why it.
Yeah, I also noticed that usually when you read a sort of like a directory for a file
Mm-hmm.
on your computer using just the usual Explorer, you go with the forward slashes, but when you're reading it, it's with the backslash.
That is a operating system thing. So on Windows, you use forward slashes only in the Explorer, but then on Macs you would use backslashes. Backslashes are much more common. The Windows one is actually one of the few antiquated systems that uses the forward slash. Yeah. Yeah, these are all little things, nuances that you kind of just have to get used to through experience. Okay, logicals. These are data types that we encountered in the last class as well. And so these are just true or false. So this is kind of your version of a Boolean in R, ones or zeros, yeses or nos, true or falses. So in R, it's true and false. And here is logical. You can see here, we test it with this function, is.logical. Of course, I didn't save it. There we go. And is.logical here. What do you guys think? False, right? So when you put it in quotes, it's a character. It no longer treats that sort of string as this Boolean object. So that's important to keep in mind. When you have true and falses, it is a special type of object that will trigger lots of things like conditionals that we talked about last time. And so you want to keep it in the form that R defines it in, which is this capital true. Although, actually, I think I found this out recently. I think you can also do this. No, or
type
oops,
true and
not that, T. Yeah, so you can do capital T and capital F to represent true and false as well. Okay. The last one, just for completeness' sake, you will not run into this in this class. I doubt you would run into this ever, unless you decide to change to a math field. Complex data type, this is for imaginary numbers. Okay, so this is complex. So you can actually see it gets stored as 0 plus 1i, right, which is, if you recall, way back in, algebra 2. That's how we denote complex numbers. And yeah, R can do it, but you almost certainly won't be encountering that in this class, at least. Okay, so those are your 5 data types. Does anyone have any questions about those? So the reason why I'm introducing you to this sort of concept formally, I think it's something easy enough to kind of pick up on your own, but you guys will find that there are lots of functions and things and operations that you'll be doing in R that kind of pertain to specific data types. And it's a very common mistake. You know, I made lots of these mistakes when I was learning this as well. That if you sort of interchange data types in certain ways, you'll be running into errors. And so this is a very common and easy place to troubleshoot if it's saying something about the data type. It's probably related to the misuse of the data types here. Okay? So next up, data structures. So we have actually already talked about vectors. So vectors, if you guys remember, using the combine function, I can create these vectors. And now I have a question for you guys. Is vector 1 numeric? What do you guys think? True or false? True. Okay, so test that. And so the way that works, even though this is an object that contains multiple items, right? If all of the items within the object are numeric, then it's going to tell you that it's true. Okay. We're going to do a different vector, slightly new because we haven't actually done this before. We are going to create a vector that contains the characters A, B, C, and D. By the way, if I were to do this, this would not work because I haven't put quotes around the ABCD, and so it actually would think that you are trying to create a vector out of 4 objects, ABCD, and because we have never defined ABCD, this would error out. And in fact, you can actually store objects in place of the items within a vector. So I'll get to that more in a second. So this would not work. Okay, but vector 2, ABCD. And what do you guys think? Is this numeric? False. But if I do is character, everything in here is a character, so true. Great. Yes?
What if you made like the second element a numeric? Like if you made like 1 plus 1 is 2, but the first element is numeric, would that still be true? Or would that be false?
Uh, We're going to get to that in just a second. That's going to be vector 3. And then I briefly had mentioned this before. I can use these square brackets to indicate that I want a subset of the vector in a specific position. So if I put vector 2 square bracket with 3, what do you guys think gets returned? C, right? So position 3 of the vector, and it would look like that. And in fact, you could do multiple ones. You could do 3 and 4, and oops, and that returns C and D. Okay? What about this?
That doesn't work because that makes the matrix of things.
Yeah, so this is actually referring to multiple positions. Remember row, column. So we're actually referencing multiple dimensions. So if you wanted to do this, you would have to put it as one object, and that would then tell it to return in the first dimension positions 3 and 4, as opposed to that. Okay? Does everyone see the difference there? Yeah.
Sorry, I guess I would have thought you would need a comma after the concatenated 3 and 4, but you don't, to say that you're just looking at the, oh, I guess it's a vector, so it's just the one.
Yeah.
Okay.
You're jumping ahead because once you're in like 2D frames, then you would have to specify specific positions. If I'm referring to the row position, I would need to put a comma and then leave the column position blank.
Okay.
But we'll get to that. Yeah. Okay. So now we're going to do a vector that has both numbers and characters. So I think this was, Christopher, your question from earlier. Okay, we're gonna do is numeric. Don't run this. And is character. Okay, raise your hand if you think is numeric is true. Okay, raise your hand if you think is character is true. Okay, so false, great, and true. What? What happened? Why is character true but numeric is false when we have both numbers and characters? There's a little hint of this, which you can see over here in the global environment. But let me make it a little bit clearer. So here's vector 1, so 1, 2, 3, 4. Here's vector 2, A, B, C, D. And hopefully you can see the difference, right? Is that numbers spelled out like here, characters like this. Characters have the quotes around them to denote that the items are each a character. And when I hit enter on here, you see the 1 and 2 both have quotes around them. Okay, and so why is this happening? So in a vector, you can only store one data type. Okay, and which data type gets superseded? Well, you can't have characters can't be represented as numbers, but numbers can be represented as characters. So when it wants to make everything generic, it's just going to turn everything into a character, right? So this is one of the common issues that someone might run into when they're trying to do some data analysis. You load in some data, right? Let's say you have an Excel file or a CSV, and you've got this column of data, and it's got all these numbers, but somewhere in one of the columns, instead of a number, someone made a little error and they put a letter in there. So R will turn that entire column into characters. And then you're going to be like, okay, let me take the average of that column, and it's going to say error. These are all characters. I don't know how to take an average of a character, right? Because it turned all your numbers into characters. So that's like a very common pitfall to watch out for. Okay. Any questions about that? Yeah.
Could you go back a little bit in the console? There's a vector 2 bracket C.
Oh, up here, yes.
Yeah, so could you go over that again?
Yeah, so square brackets are to indicate positions, and when you follow an object with a square bracket, you're telling it to return a subset of that object. So in this case, we're saying 3 and 4. So positions 3 and 4 of vector 2 is C and D, right? So what I was doing here is showing that if you do 3 comma 4, that's different from doing this or this, right? Because you're actually indicating a position as a single object, whereas here it's 2 objects, right? So remember, when you have C3, 4, this is 1 object, but here it's 2 objects, and you can't refer to 2 different positions in a single dimension like that. So if you want to get multiple returns of something in a vector, in a 1D vector, you have to pass in as a single object all the positions of the things you want returned. Yeah. Okay. So vectors are one-dimensional, but we're not confined to just doing everything in one dimension. So matrix and arrays. So matrix, you can do something like this. So here, I'm saying the first, so matrix is a function that creates the matrix. All the things inside of the matrix are in the first object. And so that first object contains all of the entries, so 1, 2, 3, 4. And we're gonna have 2 rows and 2 columns, okay? So if I run this, and then we take a look at what matrix 1 looks like, then you have 1, 2, 3, 4, right, in a little square. And notice how the matrix gets filled out. So it goes by row first, and then it fills out by column. So it goes down the rows, and then it goes across the columns. So 1, 2, 3, 4. Okay? And so this is our 2-dimensional thing. And so now when I do a reference to a reference index to a particular item within the matrix, you would have to specify 2 positions, right? So how would I return the number 2? What do you guys think? Yep. 2, 1. Yep. And that will return 2, because remember, RC cola, row, column. So row 2, column 1. So 2, 1 returns 2. If I do row 1, column 2, that will return 3. And you can actually return entire columns or entire rows. So if I wanted the first row, I would just put row 1 and leave the column blank, and that should return 1 and 3 in a vector, right? And if I wanted to return column 2, then you would leave the row blank, comma 2, and that will return 3, 4 as a vector. Okay? So this, again, is a very powerful tool for sort of parsing and filtering your data. Any questions about this? So vector, 1D, matrix, 2D, these are both specific types of arrays. Arrays is the generic n-dimensional form for these vectors, matrices, where vector would be 1D, matrix would be 2D, an array could be anything that you wanted it to be. So if I wanted a 3D object, we could do something like this. So instead of having rows and columns, you would just indicate the length of the thing in each dimension. And so we're making a 3D thing, so it's a 2 by 2 by 2 object. And that would look something like this. So I guess you can think of this as kind of like a cube, right? Where you have 8 entries. And so, yeah, if you were thinking of it like a cube, then like this would be the front face and this could be the back face, where you have 2 squares, right? 1, 2, 3, 4 is our first matrix, 5, 6, 7, 8. Okay, and so how would I return, someone tell me how I would return the number 7 as the entry. So in the same way that we're trying to return other things in the matrix and in the vector, I would use square brackets, and then what would I put in? Yeah, so 1, comma, 2, comma 2. So something like this, and that will return 7. Yeah, and you can return an entire face of your cube, right? You could do array 1, comma, comma 2, leave the first 2 blank, and that should return just this guy here. I could return the row, 1 row of that face. That could look something like this, 5, 7. Yeah, and so this is one thing that you'll just want to get comfortable with, is being able to use these indices to grab specific pieces of your data. It's one of the more sort of powerful tools that you'll leverage when you're using R. Okay. And we're gonna talk. We'll get to some more examples for this to see a little bit more powerful things that you can do when you're doing these like indices to search for values. But right now, we're just trying to get comfortable with understanding what's going on. Yeah.
When you have a matrix or like a list of numbers and you try to put it into matrix, does it always go down to the number of rows first, or does it go horizontally?
Yeah, it'll always go row, then column, and then however it'll go through each dimension successfully after that.
So rows or columns?
Yeah, always rows then columns. Yep. Okay. So I almost would classify vectors and matrices as essentially a data structure, a specific type of data structure that we call generically as an array, and those are just specific types of arrays. But there are other data structures as well. And the one that you, may kind of use as maybe a more useful tool is a list. So a list, oop, did not mean to put a space there. A list is basically just a bucket that you could just throw stuff into, okay? It doesn't care about that you need to retain specific data types or anything like that. So there are certain operations that are limited from being able to be performed on lists, where you could do it on vectors and that sort of thing, right? Because in a vector, it could know that everything's numeric. But one of the nice things about a list is it's flexible. I can throw in all of these things into a list, right? And so remember, vector 1 is a numeric vector, vector 2 was a character vector, vector 3 was a character vector, matrix 1 is a 2x2 array, and then we had a 3-dimensional array here. You can just toss them all into a list and it's totally fine. Okay? And let's look at what that list looks like. Okay, here it's that last array that we had. Over here, it's that matrix that we made. And then here it's list 1, or it's the vector 1, vector 2, and vector 3, right? And so the list is just this big container that holds all of these things. You can make a list of lists, so you could take this and throw it into a different list, and then you would have a list, and then inside of it you'd have another list. So really, it's a container that can hold anything. And the way you'll notice that there's this double square bracket thing in here. This is another sort of index value that you use to then search within the list. And so if I wanted to return vector 1, I would just do this following the list. And now I have vector 1. And the way you can think of this is you can literally get rid of this and pretend that you have vector 1 here instead. And so any operations that you would have to do on vector 1, you could just have this as the substitute here, right? And so what I mean by that is if I wanted to return entry 3, which is the number 3, in vector 1, how would I do that? In the original, right, I would do vector 1, and then I would put 3 here, right? And so if I do that, it returns the number 3, and I can literally just substitute list 1 like so, and it'll do the same thing, right? And so if I wanted to, let's say in our first array, 2, 1, not list 4, matrix, not array. So if you remember here, I want to get this value from matrix 1. If you want to grab that from that list that we made, we can do list 1, the 4th entry, 2, 1, and it'll return that. Okay? Any questions? Yes?
Just so I'm clear, the double brackets, that would be selecting the entire object within a list? Is that an appropriate way to think about it, or is it really doing something else?
No, that's right. So a list is going to just put all these objects, and it assigns this index in the double square brackets, and then you use that to find that object. Yeah, and so if you have a list within a list, then you'll have like 2 sets of square brackets that you would use, yeah, like consecutively.
So sorry, one more follow-up.
Mhm.
Can you also name, like, objects in a list instead of, like?
Yeah.
Okay.
Yeah. Let's see. I think you can do it like this: names, list one, and then we would do 1, 2, 3, fun, array. I think that works. Yeah, and then here you'll now see it renamed like that. And then the way that you would call it, you just follow the instructions in the same way. So it would be list $1 array, and then whatever I wanted, right? Like 2, 2, 2. Yeah. And I think you can also, I think you can also do this. No, or maybe. Oh, oops.
Maybe array 1.
Yeah. It has to be an atomic vector, that's right. So I'll talk a little bit more about these operators. So dollar operator versus double square bracket. They're kind of substitutable in some ways. I'll talk a little bit more about this in a second. Yeah. Any other questions? Yes.
When I run like the list one, dollar sign array 222, it turns to null or something.
That means that you made a mistake somewhere. After class, I'll look at it. Yes.
So I'm probably gonna go into this, but what are the difference between double brackets and single brackets? Besides the fact that double brackets call specifically the item and the list.
Yeah, so we're going to think of single brackets as the generic way to get an index value. Double brackets are more specific to grab usually, so they're called atomic vectors, and they're usually used to call specific names. Yeah, I'll talk a little bit more about that in a second. Yeah.
Just a really quick one. Once you name your objects, can you go back to what they originally were?
Yeah.
Erase the names, you can always change it back.
I think we can do this, list 1, and we just go back to 1 to 5. And I believe that should fix it back. No, it didn't. How do you go back to the atomic version? I don't know off the top of my head. Yeah.
I think we usually have to go all the way back to the original code and then run that.
Yeah. I mean, it's about undoing versus redoing. I'm sure you could undo it. I don't know off the top of my head how you would do it, but yeah, you could always rerun the code. Yeah. Okay. Next up, the nightmare factors. Everyone who has experience with R, who's had a problem with factors before? Yeah, okay. Factors are they're actually very useful, especially once you get a good grip of how they work and what they mean. But they're also extremely confusing, and I would probably put money on everyone running into some kind of error with factors at some point in this class. Okay, so we'll try and pay attention here because this one gets people tripped up quite a lot. Also, so a factor is a data structure and not a data type, even though I feel like it should be a data type. It's a little bit confusing. Okay, so let's just dive into it. This is a factor. Okay, we're going to have a factor is this. Okay, so I create a factor. The entries of the factor is this is a factor. And then it's got something called levels, which we're not going to worry about for just a second. And if I run this guy, we see this is a factor getting printed out. And then it's got this levels thing. Again, we're going to ignore that for just a second. What is interesting about this compared to our vector example where we had like characters? Yeah, so there's no quotes around any of these things, right? So what's going on? So is this a character? What do you guys think? No, it's not. Okay, that's kind of weird. Is this a number? Also no. So let me just, is dot character, factor one, no, is dot numeric, factor one, also no. But it is a factor. True, okay. So what is happening here? So a factor is essentially an item or entry where it's not a number, it's not a, and it's kind of like a character, but actually we have assigned some information about these things, which is that you have these levels. A factor is and this. And that actually does a couple things. It actually assigns an order to these things, and it treats it as though essentially it is an item that you could do certain types of quantitative analysis on. And so I think the easiest way for me to show this, actually I'll do it over here so that it'll get.
Can you repeat what you said about factor? You said it sets an order to the.
It sets an order to the items in here. So the order is the way that I've specified it in the levels. But let me talk about that in a second. Okay, I'm gonna pull the class once. Do you guys prefer me to do writing on the screen or on the blackboard? Screen? Okay. All right. So we will do that. Okay. So imagine that you have data. So we had this is a factor. The reason why we use this kind of factor data structure. Let's say you have a big set of data here in like an Excel file, right? And so you have columns, and you might have like numbers or whatever, dot, 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 dot. 5, 6, 7, 8. And then you have a column with qualitative information. So let's say we have this is a this factor this, okay? You can imagine some kind of data that looks maybe something like this. What R is doing kind of behind the scenes by turning it into a factor is denoting that these aren't necessarily characters, but there's information contained within here that allows you to transform these into essentially kind of like dummy variables or representations of the variables in a quantitative sense. And so you can imagine that I can actually rewrite this table like this: x1, x2, x3, and then a column called this, a column called is, a column called a, and a column called factor. Okay. And then you would have a bunch of Booleans representing where each of these guys are, right? And so this would be a 1 here, and a 1 here and here, and the rest would be zeros. And then is would be 0, 1, 1, 0, 0, 0, 0, 0. 0, 0, 0, 1, 1, 0, 0, 0, and then something like this, okay? And that is useful for many sorts of analytical purposes. You know, we're going to get into techniques that we will be able to do some data analysis on things like this. And so this is really kind of what's happening behind the scenes. You can think of what's happening as essentially this. Okay. Yes?
Is this similar to like a Python data frame?
No. Data frame, well, like the data frame there's actually a version in R, which is also a data frame that we're going to talk about a lot more. Yeah, I mean, you would store this could be stored within a data frame. Yeah. Yes?
How would you convert a factor to like a characters list or whatever? How would you do the conversion?
Yeah, so I could do that. You can certainly do that. And the way that you would do that is you would say as dot character factor 1, and it would return it into this. So the as and is things class of functions you can use to transform between data types and data structures. This is actually one of the reasons why I think it's weird that factors are considered data structures, because we're actually using a lot of the functions for data types there. But like you could do as numeric if you remember vector 3. You know, 1, 2, A, B, it'll get rid of all the characters and just leave them as NAs, since you can't have characters as numbers. Yes?
Another question. So if I put something in my factor, but I don't put that in the levels. So for example, I said this is A, B factor, and I don't put the B in the levels, then would that factor still make sense?
Yeah, let's see what happens. Um, I'm going to call this factor 2, and I'm going to leave out, let's say, is out of the levels. So the levels are also telling it information about, you know, when I drew out that table and I made these like extra columns, the order of the columns can actually be important for certain types of operations. And so when you're putting in information as a factor and you're not telling it any information about its reference point in the levels, it won't know what to do with it and it'll get rid of it. Many functions, so one of the areas, you know, I was mentioning that a lot of you almost certainly will run into issues with factors. Probably the most common one of the most common ones is when you read in files that have columns that have like character type information. Oftentimes it'll treat that as a factor, and it could sometimes it might get rid of stuff like that without kind of telling you, right? And so you would end up with NAs in there.
How do you fix that?
How do I fix this?
How would you fix that issue where it interprets another data source,
Ah.
character source as?
Yeah, so I try and avoid that by using a particular set of things to read it in certain ways, or I clean the data beforehand, or you could help it by predefining the factors when you read it in, which is an option that you can do. Yeah. Yeah.
So which are the levels the data contains?
Sorry, say that again?
I guess I'm trying to figure out how the levels are like tied to, I'm not sure what to actually call the first field, the concatenated?
These are just like the entries, basically.
Yeah.
Yeah, so the levels are a unique vector of the entries in the order that you want them to be, right? And so in here, I could put in a lot more. I could say this, a factor. Right, and it would still spit out all of those entries, but your levels are the important ones that tell you information about the relationship between all of my entries. Yeah.
It's kind of acting like some sort of mask, but I don't
So
know.
I can have more levels than my actual factor entries. So I can
Yeah.
select
Yeah.
basically saying that
Yeah, because you could have stuff that's just not in here, extra stuff not in the original, right? And so factor 2, yeah, and you would have a bunch of other things in there. Okay, and so jumping back up to here, if I can find my mouse, there we go. Levels, factor 1. This will tell me what the levels within the factor are. This is the number of levels. And then if I do something like this, should say maybe vector 2. Order tells you the index value of each value within the vector. So if you guys remember, vector 2 is the ABCD. So unless you preset some kind of some order, right, it's just going to correspond to each one. So the order of ABCD is just 1, 2, 3, 4. Okay. But the order of factor 1, who wants to tell me what they think would get returned here and why?
3, 2.
4,
4, 3, 1, 2.
4, 3, 1, 2. Okay.
Because of the order and the levels.
Yes, exactly. Yeah, so our levels specify the order, right? And so this, which is the first entry, would be the last order in the levels that we specified. So this would be 4, is in the third position, so that would be 3, A is in the first position, 1, and factor 2. So if I take the order of factor 1 based on the levels that I specified, it should be 4, 3, 1, 2. Is that what I said? Yeah. Or 3, 4, wait. Yeah, that's right. Is that right? No.
3, A. Oh yeah, 3 is A. And then factor.
Oh, yeah. Yes, that's right. That's right. A 3 factor 4 is 2, and this one, yeah. Yeah, well, I happen to put it in alphabetical order, but it doesn't have to be. And in fact, when you make a factor and you don't specify the levels, it'll automatically put it in alphabetical order. But you can have it not be by specifying it manually. Yeah.
Wait, sorry, I'm kind of confused. I was thinking it was going to go the other way. Like, so it seems like it's listing like the order of the levels, not the order of the like values or whatever.
Yeah. I think I said it backwards. It is.
The levels dictate the order and the factors.
Yeah.
Is what the inputs are.
Yeah, exactly. So it would be corresponding to which level it is.
Yeah, in my mind, for some reason, it's flipped. Like, you know what I mean? I don't know.
Yeah. Factors are confusing.
Okay.
Okay.
What does order mean here?
Order is just like which, it literally does mean just the order in which the things come. And the reason why you would want that becomes relevant for certain types of operations. Okay, why don't we take a quick 4-minute break, digest this, and then we'll pick up where we left off. Hey.
First class. Was it kind of just a crash course like this?
Yeah,
'Cause
yeah.
I know a little bit about R. So
Okay, yeah. I also post all of the
I know
notes. So,
that.
yeah,
So I
so
just kind of reviewed those.
yep, yeah, and you'll be fine.
And then like the project information. We haven't gone over like any of that. yet.
No, not yet. Yeah.
Okay, cool.
Yep.
Thanks.
In my shoe, or my shoe moving at all relative to my foot. So like if my heel is slipping at all, like from somewhere
Yeah.
So I'm kind of over the limit of my required credits. I'm
Okay.
at 16, and I wasn't sure what. I had someone talk about auditing a class, but I wasn't sure what that meant. Like, am I able to just come, get the material, learn, and not have to use it for credits? What would that
Yes.
look like?
Yeah, so auditing just means you attend the class, but you don't have to do anything really.
Okay, just
Yeah.
for learning.
Yeah.
And then what would that look like if I actually wanted to take the class next year? Will that be treated as, hey, you already kind of this or not?
No,
Yeah.
no. It just, auditing is you don't even necessarily need to like formally enroll in it or anything to audit a class. It means that you sit in, but you don't get like credits or anything. Auditing is really a way for people to
Gauge.
essentially sit into a class and learn that way. So I have always been open to people auditing the class, but the one thing that I always tell students is that one of the best ways that people are actually learning is to actually do them. When you audit, you can still do the homeworks. I can provide them, but oftentimes without people are less motivated to actually do it. So that's the main thing that I would say. Yeah, but I'm still open to it. If you
Sounds good.
if it's too much or
I mean, I'm just
whatever.
gonna talk to my supervisor about the
Okay.
load and then.
Okay. Yep.
By the way, I'm learning. It's just like what flavor of learning do I want to start with? I don't know which one's easier or better.
What feels better for you?
Like I'm pretty sure that like anything you can do in R, you can also do in Python in very similar ways. But I don't know enough about Python necessarily to
All right, so let's continue. We've gotten through the factors, which is the most confusing data structure. Want to make sure that you guys are at least familiar with the concept. So if you're starting to run into issues, hopefully you can, learning about this will help you debug. Now we're going to talk about data frames, which is probably the most commonly used data structure, and this is kind of the environment in which you guys will be sort of handling, parsing and formatting and analyzing data will be through data frames. So I would really kind of think of data frames as, if you are working in Excel or something, you have a table in Excel, like the data frame is kind of the equivalent thing that is holding all the information about that table, okay? So the generic way that we make a data frame is via the function data.frame, and you put in the entries by putting in the column name. Again, like think very analogously to Excel, like the column name as the header, you start with that, and then you would put all the entries of that column, and then followed by the next column name, entries of that column, and so on and so forth. So I'm going to make a little data frame that we're going to do a couple examples and play around with. Yeah?
One question, in this course will we mainly use base R or will we also use like tidy words?
Yeah, so so data frames as a generic in the base R is yeah, a good foundational thing. Once you're really doing bigger and you need more efficient data manipulation, um, there are I would say two main packages that kind of build off of data frame and allow you to do things a little bit more efficiently and syntactically. They're maybe a little bit easier, and there's some more powerful tools that you can do that would be kind of hard to do in a generic data frame. And so the question is, are we going to be learning about those? So I'm not going to teach about them formally. I will maybe point to them, talk about them a little bit as tools if you guys need to use them yourselves. The two main ones that I would recommend are dplyr, which is part of the tidyverse ecosystem, and then I personally use data tables for life. There's a whole dplyr data tables like rivalry in the R community, but we don't need to get into that. Yeah, but in order to be able to use those properly, you kind of need the foundation in data frames. So I'm going to sort of teach that in the tutorial bit, but I definitely would encourage you guys to learn on your own dplyr or data tables, and I've actually got some resources like tutorials that can help you guys learn that if you're interested, and I'll post those on Canvas. Yeah. I think dplyr is a little bit more popular, and I had to like force myself to learn. There's actually a good resource that I found that does like direct one-to-one comparisons between data table and dplyr. So I can share that too if you know one of them and you want to learn the other. Okay, so back to this guy. We're gonna make our data frame. So we're gonna make a column called students, and it's gonna contain 3 entries, student 1, student 2, student 3. We'll have something like ages, 24, 25, 27, gender. We're gonna make a factor. Levels equals C, F, M. Then I'm gonna do math score equals, maybe these are like SAT scores or something. Get rid of that so you guys can see. Okay, and so if I did this right, there should be no error. Yay. Okay, great. So I'm gonna leave this up for a second so you guys can type this out if you are following along. And I can show you down in the console what this data frame looks like. Okay, so I hit enter, and oh, dang it. I made a, yep. And one more time. Here we go. Okay. So this is a data frame. Hopefully not too confusing or anything, right? This is like what I was saying. You might see this type of thing in like an Excel table or something. Okay, so we have our columns, and then you have all the entries in the columns. I basically entered it manually. It's not often that you're going to be making data frames manually in this fashion, right? But here, in each row pertains to a student, and then they've got, you know, an age, gender, and some kind of score, some generic test score, for example. At those ages, maybe it's GRE and not SATs. Okay. One of the nice things about oh yes.
Why are we using levels with like gender column like the factors?
Yeah, because I decided to make this. I decided to make gender factors.
But what is the use of it? Can't we just like make it like character strings like
Yes.
M and F? But why are we like specifically using factor data types?
Yep. I'm going to show you in a second. Yeah. But I have purposely done that, right, and not define them as characters, but rather define them as factors, with the intent that there are specific operations that I might want to do, that you would only be able to do because it's a factor. Yeah.
Sorry, Saina, how do you make like that row of entries like not go all the way to infinity on the right, but like how did you make it?
Sorry, I don't.
So my row just like keep going, keep extending. Like when I keep typing, it's gonna keep extending to the right off the page.
That's just how the data frame functions. Just
There's
enter.
a way to
Can you make it
there's
wrap?
a way to make it
It's not
linear.
wrapping.
Oh. You're saying okay. You're saying this. Hang on. Like that. Is that what's happening?
So like,
Basically, like
see how like when
instead
you
of
write, it just keeps going to the right?
Up here. Oh, and not in the console. Okay, yeah. Yes, that's a setting. Yes. You do RStudio, no, file. Is it in file? It's been a while since I've had to mess with this.
I think it's tools and the global option.
Yeah. Oh, here we go, yeah. Global options, code, and then soft wrap. Yeah, this one, soft wrap source files. So that will wrap. That's what we call it. It's called wrapping. Yeah.
Should have like a scroll down to the bottom.
There we go. Okay. One of the nice things about the RStudio UI is that it actually lets you look at tables in almost kind of like an Excel format. So where is it? Okay, here we go. So I can click on it and it'll pop up here in this kind of cell form. And so you can view the data much like you would in like a kind of Excel type of format. Okay? Okay. So we visualize this in the console like this. I think you can manually pull up that viewing using this function called view. If I hit enter, it'll pull up that thing that I just showed you guys. Okay, so last time we talked about these functions summary and structure. And so here is a chance where I can actually show you guys what these functions do. Yes.
What is the difference between the data frame and the list?
Yes. A list is a container for really any sort of thing that you want, right? But I would actually, so a data frame is kind of like a particular type of list, but I would actually describe it almost as like closer to like a vector type thing, because in a data frame, it's arranged in a tabular format, so it's always in 2D, as opposed to a list, which is things that you could just, the objects within the lists can be whatever that you want, whereas in a data frame, each entry is a vector of values. It's always a vector of values, right? And so I can't like put a matrix into a data frame. It's always going to be these specific columns. So to some degree, you could make certain types of lists look like data frames, but data frames are really designed in this way so that you can do lots of different operations on them. Yeah. Okay, so when I do summary of student data, we can see here. So ignore student and gender for a second, but all of the columns that contain quantitative data, it's going to give us some summary statistics. Okay, there's only 3 numbers, but you know, it still works technically. So you get the minimum first quartile, median, mean, third quartile, and max values for all of the entries within that data. So summary is actually a really useful way, especially when you're dealing with big data sets, to quickly look at the data and see you know, what it looks like, right? I can look at the basic distribution of every column. If you have NA values, it actually spits that down here as well. It'll say NA, and then it'll tell you how many NAs there are. You can very quickly be able to look at these values and see, you know, like outlier values, you know, if there's anything that looks kind of weird in the data. Oftentimes, you know, one of the things that we do in this class, in really sort of applied data analysis, is not just jumping straight away to the analysis piece, but actually being able to look at your data and parse it even before you do any analysis and get an understanding of what's there. And so this is a quick and dirty way of getting a pretty decent understanding of your data. Okay? Yeah.
So I've just moved over to R, and I'm trying to do this data frame portion. It just says error, object, student data not found, and there's nothing in my environment. Did you run the code? I think I did. It's Control Enter, right?
Yeah. So
You need to place your cursor like before student data and then hit the Control Enter.
I don't think the cursor matters when I'm trying to run the
It matters.
script.
Like
Yeah, it matters. You have to go up.
you have to run it row by row. Yeah, it's different from notebook.
all right, you guys continue helping him. If you can't get it worked out, come after class, and I'll help look over it.
Run the entire script.
That's it.
It's not a block.
You can also do Control A and then Control Enter, and it runs the whole thing.
Okay.
So, one thing you'll notice is that in the 2 qualitative columns that we have, student and gender, they're actually being treated a little bit differently in the summaries. And so this is one of the differences when we're talking about the factors versus characters. So here it just tells you how many entries there are and that they're characters, whereas if they're factors, it's actually going to do some operations. It's going to give you counts based on the levels of the factor. It's going to order it in the levels of the factor. And yeah, so you're getting some additional information by sort of calling it a factor. And it's actually, remember when we talked about the expansion of the table into the ones and zeros, right? It's actually kind of doing that behind the scenes, so that if you wanted to do like a regression analysis on gender, it can actually do that, right? Without being like, oh, you're telling me it's a character. I don't know what you want me to do a regression on, right? So we're going to talk about that later. But yeah, storing it as a factor is kind of setting it up to be able to do those operations. questions? Okay. Oh, yes.
Is it appropriate to think about factor as like the levels are categories of discrete?
Yes, that's exactly right. And they're actually like ordered categories, although sometimes the orders may not be pertinent, but yeah.
I'm sorry, I'm still running into issues. Like, view and summary just aren't working. I'm
Yeah,
trying to
so,
make sure I have the cursor at the top. What are you using to run your whole situation?
so okay, let's look at that after class. I'll help you out with that.
Okay.
Yes.
Like if I run type of student data and it outputs list, why?
Okay, hang on. Oh, where's my mouse? So you are doing type of
Student data.
student data.
It says list.
Because technically speaking, a data frame is like a special type of list, right? It is a data frame is a list where every entry is a named vector, whereas a list can have any entry it wants, right? So technically speaking, a data frame is a type of list. We don't often think of it that way, but it is, yeah.
How does the way you set the levels
Yes.
impact terms of let's just
Yeah, okay, so watch this. So summary here, F1, M2, let's do F here, M here, and then M comes first. Yeah, so in the summary, it will show you in the order that it wants. But there's like other, you know, you're essentially storing the information about the order, and there's obviously other things that I'm not going to talk about now that the order matters, and it does it that way. Yeah. Yes.
Is there a structure of string in R?
Sorry, structures.
Like a data type of string?
Yeah, that's character. Yep.
Character.
Yeah. Okay, so str, structure, if I run this, it will tell me the structure of this object. It'll tell you the data frame with 3 rows, 5 columns, 3 observations, 5 variables, right? So observations are the number of rows, and variables are the number of columns. And then for each column, it will tell me information. It'll tell you it's a character, it's a numeric, it's a factor with 2 levels, it's a number, it's a number. And so this gives you a different type of summary about your data. This can be very useful if you are reading in like a large data set and then you want to quickly understand the characteristics of all of your variables. You just do this and it'll tell you. Okay, yes?
You can also hit the little play button in the environment.
Yep, that's right. So this is the shortcut for that. Yeah, and same information appears over here. Yep. Okay. So here is where we're going to continue building on what we've learned in terms of like the index position stuff. So student data 1, comma, blank. So what will this return? Row or column? A row, right? So row first, then column. So I'm leaving the column blank, which basically says return everything, but give me the first row. So basically, this is a way for me to display all of the information about student 1, right? So I hit enter, student 1, and it's going to return actually the whole structured of the data frame because it contains information across different variables. And if I wanted to return multiple student data, right? Let's say I wanted to return all of the data pertaining to students 1 and 2. How would I do that? Yeah, that's right. C1, 2. You didn't fall into the trap of doing 1, 2, right? Which is different. So this says, right? If you think about it as row, comma, column, you're putting 1, 2 in just the row, and right, that is different from 1, 2, which is now you're saying row 1, column 2, right, as opposed to 1 and 2 being just in the rows part. And so if I do this guy up here, that returns what we wanted, the first 2 rows, and then if I do just this one, that'll be row 1, column 2, and that'll just be 24. Yeah?
What are you pressing to get that to run just in the console?
So on Macs, it's command enter or command return, and then on PCs, it's control return.
Okay. So
that will pass an argument from my notepad into the console on the line that you're selecting.
Okay.
Yes?
Why don't you show just the header of the table?
Yeah, you can do names to get all of the column names. Yeah. Okay, and conversely, if I wanted to get all of the information about all the ages, so the second column, you can do blank, 2. Okay, and I hit enter, and I get 24, 25, 27, which is the ages. Okay, so note there's the return of the column returns a vector and not a data table. Okay, when I return a column, remember that all columns in data frames are vectors, and so it's not going to tell you, it's not going to return any other sort of information because that it's, I guess, unnecessary or redundant in some ways, right? And so when you return rows, it gives you back a data frame, but when you return a single column, it will return just the vector.
So it's always better to put something in terms of rows if you want more additional information?
Well, no, it just depends on what information you're looking for. Yeah. But if you do multiple columns, what do you guys think will happen? It will return a data frame, but it will return a slice of the data frame that you've asked for, just ages and gender. Okay? Okay. You can also call, so we saw an example of this in the lists. You can call a column by the name using this atomic vector. So it's this dollar or atomic operator $. So that'll return students. Or you can do the name via the square brackets where you put the name in parentheses, and so something like this. And I can have multiple columns here. So this you wouldn't be able to do with the $sign to do multiple columns. You'd have to do it in this way. And that will return something like this. Okay? And I can do both, right? So if I wanted verbal score and I wanted the second entry of verbal score, I would do 2, specifying that row, and then the column, and you would get that exact entry 620. Okay? And in fact, I can even do this. So what do you guys think will happen when I do this? Yeah. So this will overwrite your data, replacing whatever was in position 2 in the column verbal score, and it'll replace it with 600. So I hit enter here, and I look, it used to be 620, and I look at the data, right? Verbal score is no longer 620, it's 600. So it's been overwritten. And so the assignment operator is operating kind of exactly as we had talked about last time, right? When you assign a value to an object. Okay. Let's say I want to do a particular operation. Let's say that I want to go into my math scores, and I want to replace all the values within math score that are less than 700 with, let's say, 680. So let's say I'm the teacher, and I'm like, oh, I'm going to curve the class. Everyone who got below 680 will become 680. How would I go about doing that? Okay. So I could go manually and do student data 1, math dot score, change to 680, student data square bracket 2, math dot score to 680, right? Much in the same way that we just did that manually here. But now let's imagine that I have a class of 10,000 students. Now I don't want to do that manually, right? And so here, let's think about how we can leverage and combine a lot of the stuff that we've learned in order to do that. Yeah, so we're going to go step by step here. How would I grab that column that I'm interested in modifying? Yep, okay. So student data, so there's a couple ways we can do this. I'm just going to do math.score. Okay, great. And if I do this, it returns that vector. Okay. How can I ask whether or not, the score is less than 700? Yeah.
Your if or like case 9?
Yeah, so you could do the if, but actually I'm going to do it slightly differently. I'm going to try and do it all in one line. So less than 700. Okay, and so when I do this operation, it's going to return to me the Boolean values, so true, true, false. Okay, so I guess I didn't actually cover this yet, but okay. So let me go back to or let me do vector 2. We did something like 3, 4, right? So index value to return positions 3, 4, CD. You can also do this. False, false, true, true. So this will return only the items that are true. So CD, right? I can do true, false, true, false. That will return what? AC. Okay, that's right. So I have, if you think about it, I've actually just created this CFFTT or whatever vector with this command. So if I do this, and I want to return that vector of true and false items that I just made, right, which was CTTF, right, that's this thing. So I can literally just put that into the square bracket because that thing that we ran represents true, true, false, right? And if I run this, then it will return only the values in the column that are less than 700. Yeah. What do you want me to do one more time?
Did you get the?
Yeah.
The last thing I saw was C.
Yeah. So this used to be CTTF, and I just copied and pasted line 83 to replace that because line 83 is the same thing as TTF, right? Does everyone follow along? And so the last thing I need to do is what? Yeah, and so all I do is the assignment operator. I say those values that I returned here, change these guys to 700. And I run this. And voila, I have transformed my math.score. So we are combining a lot of the sort of things that we've been covering, right? So the indices, the conditional checks on the less than, and then the assignment operator to do this procedure. And so you can imagine that if I did have if this had 10,000 students as opposed to 3 students, right, I wouldn't really feasibly want to be changing them manually. But in fact, this code up here that we just did would apply to that data frame in exactly the same way as this one. In fact, I wouldn't even need to change any of the code. This operation would do the same thing whether or not you had 3 rows or 10,000 rows, right? And so that's kind of the power of doing things programmatically. Yeah.
I'm kind of confused on what the purpose of doing the vector, of showing the vector 2 then is for.
Oh, that was because I never covered this idea that like, doing false truths in the index positions return your CDs, the entry position of the true and false.
Okay.
Yeah. Okay. Any questions?
how would you do this replace type of operation if we're dealing with something that's not enough?
Yep. So instead of less than 700, let's do a different one. How about that? Let's change the ages for anyone who's a male to 30 years old. Okay, so then I'm not actually going to execute this, but the way that I would do that is, okay, the thing that I want to change is ages, and then the thing that I'm trying to grab is whether or not they're male. So like that, and the ages I would change to 30. So this would say change the ages of everything in the table of people who are males to 30. Yeah.
What about like changing everyone to a female?
Yeah, you could do that. So instead of changing the ages, I would change the gender, and then this would be F. Yeah. Yep. Okay.
Are there circumstances where we specifically want to use this $sign syntax instead of putting like the column name in the index?
I mean, people just say that they do it because it's faster. And yeah, it's like a preference thing. It's less flexible, but it, I guess, technically is less characters, so.
But like they sort of work the same in this circumstance.
Yes.
Okay.
Yeah. Okay. We'll do one more thing. This is like the last thing on my list, so let's just get through it real fast. Okay. Let's do a new one. Let's say I have two tables with a column like this: A, B, C, D, 3, 4, 5, 6, C, D, E, F, and this would be 7, 8, 9, 10. So this is table A, and this is table B. So what I want to explain really quickly is about merges or joins. So this is how you would combine tables together. Also a pretty useful tool. You can imagine, let's say I wanted to do some kind of analysis that I'm getting data from multiple places. So for example, if I want to do like some kind of analysis on like COVID infections as relates to like demographics, right? And so you might have a number of COVID infections by county or something, and then you have a different table from like the census where you have county and the demographics associated with those counties. And so you would put them together based on the common columns, which would be county. In this case, we're calling a generic column X as the overlap between table A and table B. So you can think of this as a Venn diagram. And there are actually 4 different types of merges or joins that you could do. There is a inner join, which is the one that most people are familiar with, where you combine it based on the items that exist in both data sets. You can have an outer join, which is you literally have all the information of everything, and then you can have a left join, which would be everything on one side, and then a right join, which would be everything from the other one. Okay, and so I think this set of examples is kind of the easiest way to visualize this. So here we go, we'll do the inner join. So what are the common values between these guys? So we have x, y, z. What are the values of x that you see in both tables? C and D, so this would be C, D, Y would be 5, 6, and Z would be 7, 8, right? Okay, an outer join would just literally have everything. So I would do A, B, C, D, E, F. In Y we would have 3, 4, 5, 6. In Z we would have 7, 8, 9, 10. And then here we would have NA. Okay? And then you can imagine a left join and a right join. These would be X, Y, Z. You would have A, B, C, D, 3, 4, 5, 6, NA, NA, 7, 8, X, Y, Z. This would be C, D, E, F, NA. Oh, sorry. This would be 5, 6, NA, NA, 7, 8, 9, 10. Okay? Everyone following along? Okay, we got like 30 seconds left. I will just do this exact, I'm just gonna do a little bit of movie magic here, and voila, okay. Remember, all the code is gonna get posted, so. Table A, table B, just exactly what I just wrote down. Column X, column Y, 3 to 6. Column X, column Z, 7 to 10. You have your inner join, your left join, right join, and outer join. You use a function called merge. X is one table, Y is another table. You join them by the column that you want that is overlapping in both of them. If they're different names, which they can be, you can say by.x equals the column name that you want in X, and by.y equals the column that you want to join on Y. So inner join, you don't have to say anything besides that. Left join, you say all.x equals true. Right join, all.y equals true. And then the outer join is all equals true. Okay? And that's joins in a nutshell. Okay, great. That's it for today, and I will see you guys next week.